Hello, everyone. So this is lecture 2, and we're going to talk about section 2.2 from your textbook, which is on linear equations in one variable. Okay, so let me describe what a linear equation in one variable is, like the form that it has. So a linear equation in one variable has the following form. Ax plus b equals 0, where a is not equal to 0, otherwise it wouldn't be a linear equation. Okay, so basically there's one variable, just the x. The a and b's are just numbers, right? There's some real number. And what makes it linear is the fact that the x is to the 1 power, right? The exponent is a 1 there. So that makes it a linear equation. And the thing that actually makes it an equation is that there's an equal sign. Okay, so before we even review how to solve linear equations in one variable, I want to talk about how those equations can be classified. You don't hear this too often. This doesn't come up in too many textbooks, but I want to review it because it is in your textbook and I think it's important. So linear equations in one variable can be classified as conditional, as an identity, and as inconsistent. Okay, so what do we mean by this? Let's look at conditional first. So conditional means that the equation is true for one value. And this is the typical case, right? The typical case is we have a conditional linear equation in one variable. So for example, if I have something, say, let's say I have this equation 3x plus 2 equals 8. Well, I can solve this for x, and I'm going to get one single answer, right? So to solve this, we would subtract 2 from both sides. So then I have 3x is equal to 6. And then to get x by itself, I would have to divide by 3, right? Since it's being multiplied by 3, I would divide by 3. So I'm going to get x is equal to 2. And we will review all the techniques for solving this in a little bit. This is just an example to show why this is conditional. So since there's one answer, when x equals 2, it makes that equation true. That means this linear equation is conditional. Okay, so basically we're saying it's true when x is equal to 2, right? So that's the condition. X has to be 2 and then it's true. Okay, identity is the second classification. This is true for all values of the variable. So the equation will be true for all values. of the variable, which is usually x, but it could be really anything. Okay, so for example, let's say I have this equation, 5x minus 3 is equal to 2x plus 3x plus 4 minus 7. And if I try to solve this, right? So again, I'm going to review all these techniques, how to solve these things, but you may remember a bunch of these. Left-hand side, I can't really do much. The right-hand side, I can combine like terms, right? I have 2x and 3x, they're like terms. So 2 plus 3 is 5, so this is going to be 5x. And then the constants are also like terms. 4 minus 7 is going to be negative 3. Then if I add 3 to both sides, well, what happens is I'm going to get 5x is equal to 5x. And then you could even go further and say, oh, let me subtract 5x from both sides. And you're going to get 0 is equal to 0, which is always true. So what this means is that in the original equation, if we go back to that original equation, so this one we started with, any value of x will make that equation true. That's what it's saying when it's identity. So let me write that down here. So any value of x will make this equation true. Okay, and you could try it, right? You could plug in, x is 0 or x is 5 or x is negative 2, and you'll find that you're going to get something on one side which is equal to the exact same thing on the other side. Again, how do we know that? Because when we tried solving it, we got this 0 equals 0, and that tells us that really that was an identity, and it's true for any particular value that we plug in. Okay, and then the last condition, the last condition was inconsistent, or the last classification was inconsistent. Let me go back to black. So inconsistent. Equation. And in this case, the equation is not going to be true for any value of the variable. So I'll say not true let me do that again. For any value of the variable. So here's an example. Let's say I have 10x minus 4 is equal to 4x plus 6x plus 7. So if I try to solve this, right? So again, on the right-hand side, I can combine like terms. The x's are like terms, so 4x plus 6x is 10x plus 7. Now I can subtract 10x from both sides to try and get my x's on one side. But notice when you do that, you're going to get negative 4 is equal to 7. Or you could even go, you could stop there, right? Or you could even go further and you could add, say, 4 to both sides. And you're going to get 0 is equal to 11. It doesn't matter, either one. In both cases, this is never true, right? Negative 4 is never equal to 7, and 0 is not equal to 11. So what does this mean? It means that there is no solution. So there's no x that will work in this case. So I'll say there's no solution, and I'll write no x will make this true. Okay, but when we classify it, we say it's inconsistent, right? So again, the three classifications were conditional. That's what we're used to, right? When we solve it and we come up with a particular value for the variable, for x, so it's true for one variable. The other classification is identity, which means it's true for any x. Really, both sides happen to be the same thing, both sides of the equation. And an inconsistent is it's never true for any value of x, right? There's no solution. And again, how do we know that? When we get to any point down here where we get something like, negative 4 equals 7, that's not true. So therefore, we know immediately it's inconsistent. There's no solution. Okay, so next, let me remind you guys how to solve various linear equations in one variable. So we'll do a bunch of examples here. So remember, the goal when solving linear equations in one variable is to isolate the variable. Right? If we can isolate the variable, then we can just read off the answer, right? For example, if we had something like, I don't know, let's say 3x plus 4 is equal to 10. If I can do some operations on both sides of this equation, so I get it so that it says something like x, which is isolated by itself, equals, in this case it'll be 2, right? Then I can read off the answer. This equation is equivalent to the original equation, but it's much easier to see the answer, right? If I plug in 2, it's going to make that equation true. So usually we just say, well, it's sort of telling us, right? X equals 2. Really, the way you would think about this is if I plug in a 2 for x, then I'm going to get 2 equals 2, which is true. But we usually just read it off, right? X equals 2 is my solution. So really the goal is to isolate that variable. So then we can easily just read off the answer. Okay, so for example, let's say I want to solve this. I'll assume that you guys have done this in the past, so most of this is going to be review. Okay, let's say that's my equation and I want to solve it for the variable, which in this case is y. All right, so what's the first thing that we do? Well, we need to multiply the first factor in parentheses by the 4. So we need to distribute in the 4. And we also need to distribute in the 5. Okay, so if I do that, I'm going to get 24y plus 4 times 5, which is 20, minus 6 is equal to 25y minus 25 plus 19. Okay, now if I look on either side of the equation, I can combine like terms, right? The constants are like terms. So what's 20 minus 6? Well, that's 14. There's no other y term, so I'll leave this as 24y plus 14 that's going to equal 25y. And then negative 25 plus 19 is a negative 6. So this is minus 6. Then I would need to bring the variable term onto one side, right? The variable terms onto one side, and the constants onto the other side. Doesn't matter what side I bring the variable on. So let me just go to the left. So I need to get rid of the positive 25y on the right-hand side. So how can I do that? Well, if I subtract 25y, that'll give me 0. But whatever I do to one side, I have to do to the other side. All right, you have to balance it on both sides. So now, what's 24y minus 25y? Well, that's negative 1y. We can just write that as negative y. And on the right-hand side, the y's are gone, right? 25y minus 25y is 0, so I just have a negative 6. And then finally, I still need to isolate the y. I'm almost there, so I need to subtract the 14, get rid of this 14. Whatever I do to one side, I'll do to the other side. So I have negative y is equal to negative 20. Almost there. I want to get one y, right? Y by itself. Right now I have a negative y. You can think of this as negative 1y. So how do I get 1y, just y by itself, which is 1y? Well, since it's being multiplied by negative 1, I'll do it over here. I can divide both sides by negative 1. Right? Because negative 1 divided by negative 1 gives me a positive 1y, which is what I want. But again, whatever I do to one side, I have to do it to the other side. So I'm going to get y, these cancel, is equal to, and then negative 20 divided by negative 1 is positive 20. So that would be my solution. How do I know that's correct? Well, I could plug it back in, right? I could go to my original equation, and where I have a y, I could plug in 20, and we'll see that it works in this case. Okay. Okay, here's another example. Let's say I want to solve this equation. I have 5 times negative 16x minus 1 plus 2 is equal to negative 20 times 4x plus 2 plus 41. Okay, so again, I need to start by distributing the 5 and distributing the negative 20. Right, order of operations. I need to do multiplication before I do the addition there. So 5 times negative 16 is negative 80x. 5 times negative 1 is just negative 5. On the right-hand side, I have negative 20 times 4x is negative 80x. Negative 20 times 4 is negative 40 plus 41. Now, if I combine like terms, right, I have negative 80x. Well, the negative 5 and positive 2 are like terms, so I can combine those to give me negative 3. And then negative 40 plus a positive 41 is a plus 1. And now, if I try to bring the variable onto one side, let's say to the left-hand side, I would add 80x, add 80x, and look what happens. I'm going to get negative 3 is equal to 1. Or if you want to, you can go further and you could say plus 3. You could say 0 is equal to 4. In any case, that is not true, right? Negative 3 is not equal to 1. 0 is not equal to 4. Therefore, what's the solution to this equation? There is no solution. Remember, this is a case where the equation will be classified as inconsistent. So no solution. And the classification of that equation is it's inconsistent. Okay, another type of equation that you might have to deal with that once you do a little bit of work, it turns into a linear equation in one variable is a rational equation. So let me review how to solve that. So solving a rational equation. So a rational equation is basically just an equation that contains at least one rational expression. So a rational equation contains at least one rational expression. And these can get pretty complicated. We're going to just deal with ones that will lead to a simple, once we simplify them, they'll lead to a simple linear equation in one variable. Okay, so here's an example. Let's say this is my equation I want to solve. 1/3 x plus 1/4 equals 2 times 3/4 x minus 3. Okay, so first thing we should do is probably distribute that 2. So multiply both terms by 2. So I'm going to have 1/3 x plus 1/4 is equal to, now this is going to be, think of this as, right, 2 over 1 times 3 over 4. So I'll just leave this as 6/4, but you could simplify it, right? In fact, if you're going to simplify fractions, you should do that before you multiply. So 2 goes into 2 once, 2 goes into 4 2 times. So then I have 1 times 3 is 3, 1 times 2 is 2. So this is really just 3 halves x. And then what's 2 times -3? That's -6. All right, now this is the part where we want to, if we can, get rid of those fractions, right? Because it's kind of a pain to deal with the fractions. We could, but it's much easier if we don't have to deal with the fractions. So the way that you do that is you multiply both sides by the lowest common denominator. So I'll say multiply both sides by the lowest common denominator, so we call LCD. And that will clear out the fractions. So to clear out the fractions. Okay, so if you look at all the denominators here, right, you can think of 6 as being 6 over 1. I have a 3, I have a 4, I have a 2. Now, the 3 is already a prime number, so I can just leave that. I can't factor any further. The 4, if we do a little tree on it, it can factor into 2 times 2, and the 2 is already prime, so I leave that. Right, that stays a 2. So then the way you figure out what the lowest common denominator is you find the lowest common multiple of those denominators, the 3, the 4, and the 2. So you factor them first, all the way down into prime numbers. So we did that. The 3 happens to already be prime, the 2 already happens to be prime. And then you look at each factor and you ask yourself, what's the greatest number of times that each factor appears in any of the factorizations? So if I look at the 3 first, the 3 occurs once, right, in that first factorization. So it occurs once here, it occurs 0 times here, it occurs 0 times here. So then what you do is you take each factor the greatest number of times it occurs in either of the factorizations. So I need to take that 3 once. And I'm going to form a product here. Okay. So Next, I look at the 2. Right? It's the only other factor. In the first factorization, the 2 occurs 0 times, right? Just 3, there's no 2 in there. In the second one, it occurs twice. In the third one, it occurs once. So what's the greatest number of times that 2 occurs in either of the factorizations? The greatest number of times is twice, right? So I take the 2 times. And when I multiply all those together, that will be my lowest common multiple of those numbers, which in this case is the lowest common denominator. So what's 3 times 2 times 2? Well, that's equal to 12. So 12 is my LCD, right? Lowest common denominator. So now what you want to do is you want to multiply both sides by 12. So actually, let me go to a new page to do this. So right now I have 1/3 x plus 1/4 equals 3 halves x minus 6, right? So I want to multiply both sides by 12. Okay, so I need to distribute into 12. Distribute into 12. So what's 12 times 1/3? Again, you could do this on the work on the side here. So 12 over 1 times 1/3. Well, I can cancel a little bit first, right? 3 goes into 3 once. 3 goes into 12 4 times. So I have 4 times 1 is 4. Over 1 times 1 is 1. That's just 4. So, and I still have an x there, so this is going to be 4x. If you do 12 times 1/4, that's going to be equal to 3. All right, just do your work on the side. Show that that's 3. If I do 12 times 3 halves, here, I'll do that one over here. Again, we can simplify, right? 2 goes into 2 once. 2 goes into 12 6 times. So 6 times 3 is 18 over 1. That's just equal to 18. So this is going to be 18x. And then 12 times a negative 6 is negative 72. Okay, so now I've cleared out all my fractions, which is great, right? Now I just have to deal with isolating the variable. So let me bring the x's to the left-hand side. So I'm going to subtract 18x. So I have negative 14x plus 3 is equal to negative 72. And then I'm going to get rid of the 3, move it over to the right-hand side. So I'm going to need to subtract 3 from both sides. So now my x is isolated on the left-hand side. So this is what? Negative 72 minus 3 is negative 75. And then finally, to get 1x, or x by itself, since it's being multiplied by negative 14, I need to divide by negative 14. Right? That'll cancel, and I'll get what I want, x. Well, a negative divided by negative is positive. I can't really simplify 75 over 14. Nothing will go into it. Or there's no factors that'll go into it. So my answer is just going to be 75 14ths. But positive, because negative divided by negative is positive. So that would be the answer. Okay, and then in class, I will do more examples of this. So just for the video lecture, I'm just going to do that one example. All right, the next topic I want to talk about is finding a linear equation. And in particular, I want to write the equation in what's called the slope-intercept form. I'm sure you guys have heard of this. The linear equation, if it's in this form, has the following equation. It's y is equal to mx plus b. okay, where m is the slope. And we'll talk more about slope in a little bit. And you can think of the slope as like the average rate of change, or in terms of a graph, it measures the steepness of the line. I'll just put it measures the steepness of the line. And then the point 0, comma b is the y-intercept. Remember, that's where the line crosses the y-axis. Sometimes we say, b is the y-intercept, but really, if you're being careful, the y-intercept is the actual point, right? It's an ordered pair. It's x comma y. So in this case, it would be 0, comma b would be the y-intercept. Okay, let me remind you how to compute the slope. So let's say I have, here I'll draw a Cartesian coordinate system. Let's say I have a point here and a point there. I'll call this point, say, x1, y1, and this one x2, y2. These are my axes. So I want to find or compute the slope of the line that passes through those 2 points. I'll just draw it as a line segment right now. So I want to find the slope of this line. Again, it's a measure of the steepness of that particular line. So as you guys may remember, right, to compute the slope, it's going to depend on what's called the rise, which is the change in the y value. So it's something like this. Do it in blue. Maybe to there. Over the change in the x value, which is the run. So this distance right here is the rise. And then this distance right here is the run. So to compute the slope, we can write this as, there's several ways we can write this. We can write it as y2 minus y1, so the change in the y values, divided by x2 minus x1. That difference, so the y2 minus y1, some people will call that delta y. Delta means change, so that triangle means change in y over change in x. So it's always 2 minus 1, or final minus initial. And then some people call the change in the y the rise, which I drew on the graph there, over the change in x is the run. Okay, so y2 minus y1 over x2 minus x1. So given, let's do an example here. Given the points -1, 9 and -4, 0, find the slope. And really, I mean find the slope of the line passing through those points. Okay, so it doesn't matter what you label the ones and what you label the twos. So what I do is the first point I see, so we had negative 1, 9 first, just call that the 1. So this is x1, y1, right? Remember, it's always xy. And then the second point that I saw, negative 4, 0, I'll call that 2. So this is x2, y2. So the slope, remember, it's always going to be y2 minus y1 over x2 minus x1. So in this case, it would be 0 minus 9 over negative 4 minus, you got to be careful here, it's a negative 1, right? Minus a negative 1. So 0 minus 9 is the same thing as 0 plus a negative 9, right? This is just negative 9. And then negative 4 minus a negative 1 is equivalent to negative 4 plus a positive 1. So this is going to be negative 3. And we can simplify this, right? Negative 9 divided by negative 3 is a positive 3. So in this case, the slope is simply a positive 3. Okay, there's another form of a linear equation that is often useful. It's called the point-slope formula. So let me write that down to remind you of that. So the point-slope formula. So given a point, in general, let's just call it x1, y1, and the slope m, the equation of the line can be given in this form. So this is the point-slope form. So it would be y minus y1 equals m times x minus x1. So again, x1 and y1 is that given point, right? So I'd have to give you those two coordinates, right, for that point. The m is the slope, and then the x and y by itself are just your variables. They just remain as x and y. Okay, so an example, you could be asked to find the equation of a line that meets some criteria, right? So let's say we're asked to find the equation of the line that passes through let's say negative 7, 6, and it has slope, say 2/7. Okay, so if I look at that question, what information am I given? Well, I'm given the slope, so I'm given m, right? M is just 2/7. And I'm also given a point that the line passes. So I'm given the point, I'll call it x1, y1. So now we can use the point-slope formula to find the equation of a line. Because remember that it says that y minus y1 has to equal m times x minus x1. So if I plug everything in, y remains y. Y1 is 6, right? So minus 6 equals 2/7, and an x minus, and an x1 is a negative 7. So you get to be careful again with the signs there. So this is the same as y minus 6 is equal to 2/7 x, and then minus a negative 7 is the same as plus 7. Okay, so basically that is the equation of line, but typically what we do to get for the final result is we write it in the slope-intercept form, right? We have y equals mx plus b. So we can easily do that. To get it in that form, I'm going to distribute into 2/7. So I have y minus 6 is equal, well, 2/7 times x is just 2/7 x. And in 2/7 times 7, if we do it on the side over here, think of 7 as 7 over 1. These cancel, right? You just get 1 over 1. So this is just 2. So plus 2. And then one more step, I just need to isolate the y, so I need to get the negative 6 on the other side. So I'm going to add 6 to get rid of that negative 6. And whatever you do to one side, I have to do the other side. So I'm going to get y is equal to 2/7 x plus 8. So that would be the equation of a line that passed through the point negative 7, 6 and had a slope 2/7, and it's written in a slope-intercept form. So let me note that usually the final equation is in slope-intercept form. Which is y equals mx plus b form. Typically, that's what we want for the final equation. Okay, another form of the equation of a line is called the standard form. So the standard form is this form: ax plus by is equal to c, where a, b, and c are just real numbers. And it's also important, let me write it here, where a and b are not both 0. One of them could be 0, but not both of them. Then it wouldn't make sense. It wouldn't be an equation of a line anymore. So I'll say where a and b are not both 0. But one of them could be 0, and we'll see that in a little bit, actually. Okay, so as a quick example, let's say I give you some equation of a line. Let's say it's in slope-intercept form, and I want to write it in standard form. So I want to write y equals 4x minus 7 in standard form. Okay, so how do I do that? Well, I have to get it in this form as ax plus by equals c. So basically, I need to get the x's and y's together on the left-hand side and leave the constant on the right-hand side. So really, in this case, all I need to do is move the 4x, right? Get rid of that 4x on the right-hand side. So I can do that if I subtract 4x on both sides. Now, the left-hand side I can write as negative 4x. I'll write that term first, plus y. And then on the right-hand side, I just have negative 7. And that's it, right? So now this answer, it's the same line, same exact equation, except it's written in standard form as opposed to the slope-intercept form. Okay, so remember earlier I said in standard form, both a and b can't be 0, but one of them could be 0. Here's where the situation comes up where one of them is 0. And sort of like a special case, it's where we're going to have vertical and horizontal lines. So let's talk about vertical and horizontal lines. Okay, so for example, let's say I want to graph this line, x equals -3. I'll do a Cartesian coordinate system here. I'm just going to draw it out instead of cutting and pasting a nice one in here. By the way, how many tick marks do you draw when you randomly do one of these? It depends, right? You have to draw as many as you need. Usually what I do is I draw like 5 or 6. So positive, negative, and then same thing on the y. Like up, say 5 or 6, and then down 5 or 6. But you may need more. It depends on the problem. Okay, now at first, this doesn't even look like it's an equation with a line, right? It looks like it's just giving us a single variable and it's telling us that it's -3. But we have to imagine that we're dealing with 2 variables, right? So it's implicit that we're dealing with an equation of a line. In fact, if we write this in the standard format, remember standard form is ax plus by is equal to c. I can write this as 1 times x, right? Because I have an x there, so the a is really just 1. Plus, since there is no y, I can make the b 0, and then the c would be -3. So it really does fit that standard form, right? So we're assuming that there's both variables x and y, that we actually have a line here. All right, so to graph it, let me make a little table like we normally would. So I have x and y values. Now, if you think about it, right, it doesn't matter what you choose for a y value. When you plug in that y value, so I'll just make up a few values, say -2, -1, 0, 1, and 2. If I plug in -2 there for y, what's going to happen? Well, I'm going to get 1 times x plus 0 times -2 is equal to -3. Well, 0 times -2 is 0, right? So I just get x is equal to -3. So when y is -2, x is -3. If I plug in the second value, say -1 for y, I'm going to get 1 times x plus 0 times -1 equals -3. And again, what's 0 times -1? It's 0. So I'm going to get x is equal to -3. So notice that it doesn't matter what you plug in for y, you're always going to get x is equal to -3. So if we plot some of these points, so -3, -2 would be here, right? -3, -1 here, -3, 0 is here, -3, 1, -3, 2. And then I graph that line. We're going to find that it's a vertical line. So this is a vertical line. So in general, an equation of the form x is equal to a constant, usually we call it a, so I'll just say this is a constant, right? X equals some number. It's a vertical line. So if you see x equals 2, x equals -5, x equals 17, that represents a vertical line. Another thing we can do is we can compute the slope of this line, right? So let's choose 2 points. Let's choose, let's say -3, 2, so this point, and then -3, say -1, this point. And let's calculate the slope based on those 2 points. Let's see what the slope of a vertical line is. So if I use the point -3, 2, and then -3, -1. So this is like my x1, y1, x2, y2. And again, it doesn't matter which you label the 1s, which you label the 2s. So the first point I see, I label the 1s. Second point, I label the 2s. So we have the slope is y2 minus y1 over x2 minus x1. So this will be -1 minus 2 over -3 minus a -3. So -1 minus 2 is -3. -3 minus -3 is -3 plus 3. That's 0. And what is -3 divided by 0? In fact, what's anything divided by 0? It's undefined. Remember, you can't divide by 0 in mathematics, so we say it's undefined. Some people will say it's infinite, but really the best answer is it's not defined or undefined. So what we're saying is that the slope of a vertical line is always undefined. So the slope of a vertical line is undefined. Okay, so that's like one special case. What about the other special case? Let's say I want to graph the line y equals 4. So again, it doesn't even look like the equation of a line until you really think about it. I can put this in standard form right, by writing it as 0 times x, so the a is 0 in this case, plus 1 times y is equal to 4. So now if I make a little table of x and y values so I can do my plot, now it doesn't matter what I choose for x, right? I can plug anything in for x. And when I plug that in and I solve for y, what am I going to get every time? I'll just do one of them. So if I plug into -2, that's gone, right? 0 times -2 is 0. This is equal to 0. So this just says y is equal to 4. So when x is -2, y is 4. If you plug in -1, you're going to get the same thing. Y is 4. Plug in 0, y is 4, and so on. So no matter what x is, the y value is always going to be positive 4. So if we plot some of these points, so -2, 4 is like here, I guess. -1, 4 is here. 0, 4, 1, 4, 2, 4. So I guess this line looks like this. So this line, right, is a horizontal line. It has the equation y equals 4. And you can argue in general an equation of the form y equals a constant. Usually in this case we call the constant b, but it's just some constant, it's just some number. In this case it was 4, right? But it could be anything. This is all. That's always going to be the equation of a horizontal line. So I'll say is a horizontal line. Now, just like before, we could calculate the slope of this line. So let's choose 2 points. I don't know, I think I used -2. I used -2, 4, so this point, and then +2, 4, that point. All right, so based on those 2 points, let's calculate the slope. And let's see if this makes sense. So I chose -2, 4, and then +2, 4. So I can call this x1, y1, x2, y2. So the slope is always y2 minus y1 over x2 minus x1. So in this case, it would be 4 minus 4 over 2 minus a -2. Well, 4 minus 4 is 0, right? So the numerator is 0. 2 minus a -2 is the same as 2 plus 2, which is 4. But then 0 divided by anything, as long as that denominator is not 0 itself, is what? It's equal to 0, right? 0 divided by anything is 0. So we found basically that the slope of a horizontal line is always going to be 0. It's always 0, okay? Now, again, that makes sense, right? Because remember, the slope represents the steepness of the line. So if something is completely flat, right, if it's horizontal, it has no steepness. So it makes sense that the slope should give you a value of 0, right? It is, I'll say it is completely flat, right? A horizontal line is completely flat, which means that there's no steepness to it. So it kind of fits in with the fact that the slope is a measure of the steepness. Okay, I'm going to do one more little part where I discussed briefly parallel and perpendicular, what that means. And then I'm going to save, I didn't do all my examples. Many of these examples I'll do during the class period, right? When we meet face to face with half the class. I'll do more examples and answer any questions you guys might have. So let me talk just a little bit about parallel and perpendicular lines. So determining whether graphs of lines are parallel or perpendicular. Okay, so let's say I have these two lines. Draw my Cartesian coordinate system here. So x, y. Let's say they look like this. So this first line, say, has the equation y equals m1x plus b1. And the second one is y equals m2x plus b2. Okay, so how do I determine whether two lines are parallel? This is a case where they're parallel, right? Parallel means they never intersect. So I'll say it means two things, right? It means that, so parallel means the slopes are the same. And the lines never intersect. So if you were to draw if you extend those lines forever, they would never cross. So how do we determine, like, what's the test to see whether something is parallel or perpendicular? Well, two lines are parallel if, and we kind of said it above, if m1 equals m2, right? The slopes are the same. And we also have to say that the y-intercepts, the b's can't be the same, right? They must be different. b1 is not equal to b2. Because if they were the same too, then they'd be exactly the same line, right? They have to be two distinct different lines. So slopes are the same, but the b's are different. That would mean the two lines are parallel. All right, what about perpendicular? So in this case, let's say I have my Cartesian coordinate system. That was bad. And let's say I have a line that does that, and then a line that does this. So again, I'll call this y equals m1x plus b1, and I'll call this one y equals m2x plus b2. What does it mean to be perpendicular? It means that when they intersect, right, they're going to intersect, and they're going to intersect at a right angle, at a 90-degree angle. So this is 90 degrees. So I'll say perpendicular lines intersect at a 90-degree or right angle. Okay, what's the test? I don't know if you guys remember this. You might remember this from elementary algebra. So two lines are perpendicular if, and the test is if m1 times m2 is equal to -1. So if you multiply the slopes together and you get -1, then they're perpendicular. Or another way of saying this is, or if m2 is equal to -1 over m1. Okay, so basically what I did is I just I solved that equation for m2, right? Divide both sides of m1, I'm going to get -1 over m1. In words, you could say if one slope is the negative reciprocal of the other, the lines are perpendicular. Okay, I want to do, let me do one example, and I'll do more examples in lecture when we meet face to face. So let's say you're told you have line 1, and you're told that it passes through the point -1, 3, and 4, -6. And then we have, say, line 2, and it passes through the points 0, 4, and 5, -5. And the question is, are the two lines parallel, perpendicular, or neither? So are the two lines parallel, perpendicular, neither. Okay, so what's going to allow us to determine this answer? Well, we need to compute the slope, right? We need to compute the slope for the first line. We need to compute the slope for the second line. So if we do this, I'll just call this, I'll say line 1, right? We know it goes through -1, 3, and 4, -6. So I'll call this x1, y1, x2, y2. And I'll do the same thing for line 2. So I'll do it over here. So line 2, it passes through 0, 4, 5, -5. So this is x1, y1, x2, y2. Okay, so let me compute the slope for both of those. So the slope, as usual, is y2 minus y1 over x2 minus x1. So this would be -6 minus 3 over 4 minus a -1. So that's going to be -6 minus 3 is -9. And then 4 minus -1 is +5. So it looks like -9 fits. And then the other line, I have -5 minus 4 over 5 minus 0, right? y2 minus y1 over x2 minus x1. But -5 minus 4 is -9, and 5 minus 0 is 5. Let me call this M1, and this is M2, right? So slope for line 1, slope for line 2. Okay, now just by that information, what can we tell? Well, the slopes are equal, right? So these lines are parallel. Now, they could really be the same line too. We could determine that to make sure they're really not the same line by plotting this. Actually, let me do that real quick. I'll pause and come back. Okay, so just to double check, right? We found that the slopes are equal, so the lines must be parallel, but I just wanted to make sure that they weren't exactly the same line. You could do that several different ways. In this case, I just chose to graph them, so I plotted those 2 points, drew the line through the 2 points, and we can see that both lines are different, right? They have the same slope. They're both -9 fits for their slopes, but they have different y-intercepts. In this case, the top line has a y-intercept of 0, 4, and this one is 0, I think it's 6 fits. So the answer to this question is these two lines are parallel. Okay, great. So that's it for this particular video lecture. I will do more examples and more problems during class time. Excellent, thanks.